Welcome all. Let's continue to our learning series on the flow strategies need to be deployed in any HVAC system. So we'll understand in this how constant flow strategies can be utilized for any HVAC system. Let's continue. With the constant flow water system, in this we are going to discuss what all are the applications wherein the constant flow chill water strategies can be deployed. One can be single chiller serving to a single cooling load. The second can be single chiller with multiple cooling loads. The third can be multiple chillers put in a parallel to serve the multiple cooling load requirement, and multiple chillers put in the series to cater the multiple cooling load requirements. So here you can see it is constant flow system with single chiller and the single coil. With single chiller and single coil, the simplest design strategy to eliminate the traditional three-way valve at the coil and use the constant pump to circulate water between evaporator and the coil. The control is provided by resetting the temperature of the chill water leaving at the chiller. The constant water flow provides the reliable heat transfer at both evaporator and the cooling coil. Also, the chiller performance is improved when leaving chill water temperature is reset whatever it is required. When the dehumidification is required at the low load conditions, temperature of the air leaving at the coil can be reset to achieve the necessary dew point temperature. It is often in the constant flow system, single chiller, single coil may require a storage tank to ensure the water pipeline is fully occupied and the coil is fully occupied with the water. The minimum water volume should be verified with the chiller manufacturer. So here you can see it's a constant speed pump and there is a storage which has been provided over here. And the flow requirement, if I'm talking about for any screw chiller, it can be 2.4 GPM per ton. And for any recip or scroll compressors, it can be 5 times recirculation rate for both of these categories of the compressors. So let's go into the detail. If there is a single chiller with multiple cooling load requirement, a constant chill water flow is the simplest and the cost-effective design for the plant by providing a three-way coil, by providing a three-way valve in the system. A variable flow system may be more cost-effective if the distance between the chiller and coil is too large and head over the pumping is more than 50 feet. In the constant flow system, a three-way valve is being provided. Here you can see this is a three-way valve. A simplest strategy which can take care of the variable flow requirement, but it is having its own challenges and the issues. So let's discuss a three-way valve is to require to modulate the load at the cooling level. The second is the reset of the chiller leaving temperature is required to conserve the energy and the cooling load demand. Now it also assumes when three-way valves is being provided, if there is a flow or a part load condition wherein the 50% of the cooling is required, the three-way valve doesn't modulate the flow to take care of the 50% of the reduced flow. So let's see with an example. So here it is a single chiller with multiple cooling load requirement. Here you can see this is a single chiller. There are two load requirement with three-way valve are integrated. Talking about 100% of the coil requirement, 50% of the coil requirement and 0% of the coil requirement. In all three cases, the flow is constant. The pump is continuously pumping 100 GPM of the water to the system. Here you will see at the 100% of the coil requirement, the flow is at 100 GPM at the cooling load. When coil is at the 50% of the load, the partial load condition, when the flow has been increased with 120 GPM, which means it shows that pump is pumping more water to one of the section of the cooling coil, which create inefficiencies into the system. To eliminate this, two-way walls are the best wall can be utilized in any HVAC system to eliminate such kind of requirement. The second is multiple chillers with multiple cooling load. So it is a constant system, can be piped in multiple chiller, either in parallel or series. So let's discuss first in series, the parallel, how it is going to be. So there are two chillers which are configured in the parallel. There are two dedicated pump and two or multiple load requirements which are there at coil A and coil B. It is the best proposition if there are two chillers which are working on the full load and the coils are also at the full load requirement. Both of these pumps are going to pump the water. Let's say if it is 100 GPM at one and the second is 100 GPM, 200 GPM of water is going to be pumped into the entire system when both of these cooling loads are at the peak. When there is a one coil which is not requiring any water because of no operations or no demand at the load side. In that particular case, 50% of the water is going to be bypassed and the coil which is at full load, the coil 1 which is at a full load is going to only experiencing the 50% of the flow and the coil is going to stop. In that particular case, the second pump also need to be pumped to ensure that coil is getting water. Sometimes the chiller also need to be operational, which is creating inefficiencies into the system. Let's say if I'm configuring this into a series configuration, the series chillers are configured in the series and the load are there at the multiple. So if multiple chillers are provided into the series, here you can see this is chiller 1 and this is chiller 2. That is water is entering at 60 degree Fahrenheit, 50 degree at the living temperature, and the second chiller it is living at 40 degree Fahrenheit. This is one of the good case when two chillers are in series. It is creating a problem when more than two chillers are going to be there in the system. It also create more pump head when two chillers are in the series. So it is effective when there is a high delta T chiller design configuration which is there in the system. Or the second, it can be used when two different category of chiller are there. One is adsorption and the second is electrical driven chiller. So one can be electric chiller or the compression chiller, second can be adsorption chiller, and based on the duty conditions, based on the power tariff, someone or operator can make a choice which chiller to go first. So thank you for joining in today's video. We will be more talking about the variable flow strategies in the coming video. Thank you so much.